Hello, everyone. We are group number 2, and my name is Jorge Vasquez. My teammates are Jesus Bensojo and Chinedu Oputa. Today, we will be talking about high volume testing. These tests are, like we have here, automatic random testing, performance, recovery, and stress testing. So, automatic random testing is injecting large quantities of random inputs, random numbers, random data into a system and see what happens. The reasoning behind it is trying to see what happens when a system receives random tests or random data that is not designed for, and see what happens. Automatic random testing has some downsides, like it's hard to predict results. We don't know what's going to happen. We may not be able to find solutions to a problem that may come up, since it can be randomly generated. And the other downside is that the tests have to be feasible, have to be plausible. Otherwise, we'll be just wasting resources and time. I can relate this to the drone project that we have going on in class. We can throw in a lot of inputs into the system, like addresses for the drone to deliver medicine, weather conditions, ranging randomly. The test should not try to make it go to, let's say, Europe, because we know it's not going to make it. So if we would try to do that test, then we know it's going to fail. So since automatic random testing can have some drawbacks, there's the enhanced random testing, which pretty much predetermines how the randomization of data is going to be done. So we have parameterized random test data generation, which in short is we're going to set a specific parameters for our test generation software. Again, going back to the drone, in this case, we could go and set up a set of parameters under which we're going to test the system. We can probably say travel 3 miles in diameter or around the facility and hit specific points and see if it works. The next one is directed automated random testing. This one is pretty much running sort of like a software or an algorithm that will go through our software and test to see if our interface is working. For example, on the PMO project, we can have a test where it will try to input random data into different fields and see what happens. Maybe it will demonstrate to the test engineer that the fields are not case sensitive, are not being validated, and then this system will actually allow us to find solutions and detect crashes of the system. Our next test is the specification-based random testing, and this one is based testing that specifications are properly done. What this means is that the developer really needs to know their system, pretty much predict how it's going to react to specific cases. This test will pretty much allow us to see if our system is meeting specifications. State model random testing will allow us to test different states of a machine. Let's say, for example, a vending machine. Based on the inputs the money that we put in, and then the inputs, it's going to produce a state. It will give us something based on a predetermined processes already in place. And pretty much what it will do is what happens when we change a random testing it will tell us what happens when we do random inputs into the system. The next one is random testing of interrupt-driven embedded systems. It's more of a hardware test. Let's say it will help us test how resilient CPU is when interrupts are sent to it, and pretty much again see what happens. Regression random testing refers to, let's say we test our portable shower water recycling system, and it passes all of our tests. Then we go back and apply the same test, but in a random order, and then we see what happens. And then we hope to make it fail so that we can detect anomalies and correct them before deploying. Finally, random testing of integrated circuits. This is more of a pretty much testing like motherboard or integrated circuits, both analog and digital, and inputting random data or random inputs into it, again, to see how it reacts. The next form of testing is performance testing. This is pretty much testing our system to determine if it's meeting the performance requirements that have been specified. Needs to have very controlled measurements and behavior analysis and data collection performed, because we want to make sure that all of our systems, subsystems, and components are performing both individually and as a group, as a part of a system. So the basic question that this is trying to answer is a system capable of making our customers happy? If our system is not performing, then we're gonna have grumpy customers yelling at us because the system is not performing. So again, as I mentioned earlier, we should also perform tests on each component, on each subsystem, and then the system as a whole, to make sure that the whole system performs as indicated. There's a case study that a car manufacturer in Europe started outsourcing a lot of their parts, and then they started outsourcing complete systems like brake systems, like safety systems, airbag deployment systems, all that kind of deal. So in the long run, the subsystems were designed as specified by the car company, but when they were brought together, they had serious performance issues because they never tested everything as a whole. They just tested individually. So that kind of testing needs to be done at all levels. Also, on the same vein, on the same scenario, the performance needs to be tested before a system is deployed or fielded, because it can be very costly. You can have recalls, you can have accidents, you can have even deaths due to not testing performance of the whole system, like in this case in a car, and it will produce very, very bad consequences to the company. So how do we do performance testing? So we begin with a performance test plans where we're gonna have all of our documentation, all of our testing procedures. How are we gonna test the system? What tests are we gonna use? What software are we gonna use? What tools are we gonna use? What is expected of the system in regards to performance? How much money is it gonna cost? How many tools do we have to buy? How much training do we have to get, etc. Also, an environment simulator can be used, like a wind tunnel, or we can use software to test our software to test pretty much. Part of the performance numbers that we can test include task response times, which is how long it takes to perform task. System external capacity, how many external systems, communications, or users can the system handle at the same time. Resources, again, how many resources are used by the system on a given time. Reliability, how stable is the system under maximum required workload. So the steps to perform a performance testing. First is document the performance requirements that they're coming in from the system specification. Then develop a performance test procedure, which can include elements like parameters to be tested, test resources, engineers, facilities, environments, configurations, etc. Next step is to obtain the tools that we're going to use to test. It can be either software, it can be hardware, it can be facilities, etc. Step 4 would be to develop our test scenarios, scripts, and pretty much determine how are we going to test. Step number 5, develop the performance testing environment, and then install all of our tools, set up our environment to be ready to test and capture the data that will be produced. Step number 6, the fun part, execute the performance and see if our system is developing up to what it's supposed to be doing. We have to collect the data, the results, create statistics, create graphs, and then make a determination to see if the system actually performed as expected. If our system doesn't perform as expected, we have to carry out corrective actions, fix our system, bring in the engineers, bring in the resources to have our system perform as expected. And finally, generate a performance test report so that we can refer back to it and indicate whether the system is performing up to standards. Our next topic is recovery testing. We use this to determine if a system can recover from an error. And I can relate this to like a data center where their other servers have redundancies, they have failovers, they have all these other systems that they use to maintain operations and ensure continuity of the business. So these systems can fail in many different ways, from maybe a power outage, it could be hardware failure, freak accident, etc. So these systems also have automatic recovery systems that are able to determine if an error has occurred, fault is happening on the hardware, and recover from it. So again, I refer back to the scenario where a data center may lose power. So what's the system going to do? Well, it's probably going to revert back to generator power, start minimizing resources that it might use, create a quick backup, et cetera, et cetera. It has a bunch of procedures, predetermined procedures that it's going to deploy as soon as it detects a failure. So part of the recovery testing is determining how fast the system recovers from failure and if any of our data has been impacted, deleted, compromised in any way after the system has recovered. And then measuring how long it took for the system to come back from failure. Finally, we'll talk about stress testing. Stress testing is very similar to performance testing, with the difference that on this one, we're trying to break the system. We're trying to break our product. Let's say, for example, in our shower water recycling system, we would try to see what would happen if we don't change filters for a month. That thing would get filthy, would be disgusting. So we're trying to see how far our system will go and how far will it produce favorable results, or if it's going to break, if it's going to stop working. And one of the points of stress testing is to validness and elasticity. Robustness refers to how much can the system take until it breaks. How many different inputs can it take? How many unforeseen circumstances can it withstand before it breaks? Elasticity, on the other hand, is how much how fast can the system recover from this unexpected stress that it's being bestowed upon. So after we do, pretty much again, to repeat myself, stress testing is to try to break the system, see if our system can take it, see if it recovers as intended and keeps working as intended, and then we'll review our tests to see if there's any anomalies, that can be prevented or can be used to improve our system.